ठीक है ऊपर
ठीक है
तो उत्ते जाके बड़ा बड़ा सीधा मेरा घर इन्हों की मैं रिकॉर्डिंग ला दूँगा रिकॉर्डिंग कितने लगनी है
गाड़ी ला के जो अपने कैमरे से
यही रिकॉर्डिंग लाती है या क्या जो प्रोग्राम पूरा सेटिंग करके आ जा कालू आऊँगा यार कवर होया काल इंशाल्लाह कालू आऊँगा पक्का आऊँगा देख के लिया और जो टेबल आया ना
टेबल से कोई नहीं
आप बहुत से बिना लोगों से
Okay, good morning. Good morning, ladies and gentlemen. So we'll start our session on composite materials.
In the name of Allah, the most beneficent and the most merciful, esteemed guests, invited dignitaries and delegates, Assalamu alaikum and a very good morning. We are very pleased to be able to welcome you all to the second day of the third International Conference on Knowledge-Based Textiles, ICKT 2024 at the National Textile University. We, Rashid Latif and Alika Shahid, once again welcome you all here.
Good morning. So, ladies and gentlemen, without further, we are going to start our today's session. Firstly, which will be shared by Professor Bo Hongbu from Dongguo University, Shanghai. Please put your hands together to welcome Professor Bo Hongbu. Let us provide a brief introduction about our first session. Professor Bo Hongbu is a distinguished professor in College of Textiles, Dongguo University, Shanghai, China. He did his PhD in the Department of Textile Materials from China Textile University. His research focused on design and mechanics of textile composite materials. He has established or published more than 280 papers in international peer-reviewed journals and 6 monographs on textile composites, materials and textile engineering. Sir, now I hand over the session to you. Please continue.
Okay, thank you for the introduction. Ladies and gentlemen, so we start our first session on composite materials. So this morning we have 8 presentations. The first is from Professor Sambuang from University of China, Malaysia. So Professor Sambuang is a professor and PhD and has published more than 950 international journal articles and 55 books, and have received many awards, especially for ISB Outstanding Achievement Award, William Johnson International Gold Medal, and etc. So today this talk is for development and characterization of graphene nanoplatelet reinforced PA composite. So Professor Small, it's your turn. You have 25 minutes.
Thank you, Professor, for the introduction. Assalamu alaikum wa rahmatullahi wa barakatuh. And good morning, ladies and gentlemen. The title of my presentation today is Development and Characterization of Graphene Nanoplate GNP Reinforced Polylactic Acid PLA Composite for Electric Vehicle Battery Pack. So the co-author for this presentation, Dr. Wasiuddin Siddiqui, the postdoc at UPM, Yusuf Jamil, PhD student, and Dr. Muhammad Rushdi, the co-worker for this project. The outline. After introduction, I will talk on electric vehicle battery enclosure, solution for electric vehicle battery enclosure, bio-based sustainable composite, design principles, material selection, methodology, results, challenges, conclusion, future work on electric vehicle batteries, and achievements. EV are rapidly replacing those powered by conventional energy sources in every aspect of daily life. The material used in battery casing play an important role in deciding the safety of the vehicles. Battery casing need lightweight and sustainable materials. Battery casing is a vital part of electric vehicles. Battery pack for battery electric vehicles are characterized by high energy density and high energy content with low power densities. This is electric vehicle battery system structure. We focus on battery pack. Actually, this is part of the research. We received a grant from in that industry, 1 million. But I'm really part of that team, just to assign to develop the battery pack. This is part of the review, literature review that is currently being under review in Renewable and Sustainable Energy Review Journal, FCPM. So it shows the dependable battery pack that has one battery module placed in each compartment of the battery pack. This is another version of the battery pack from literature. This is how the battery pack is placed in the car. Okay, the battery enclosure, battery pack, crucial element of the vehicle protect the battery cell and provide structural integrity. There is growing demand for the development of lightweight, durable, and cost-effective material for battery enclosures that can increase the range of electric vehicle without sacrificing safety and performance. And this is the previously material used for that, including steel, aluminum alloy, stainless steel, carbon composite, and others. Okay, the problem with electric vehicles battery enclosure, currently aluminum alloys and carbon composite are used, and heavy weight and aluminum alloy and non-biodegradable carbon composite are the major problem encountered in the materials currently used for making the battery enclosure. Okay, at the end of the electric vehicle's life, or when the battery needs replacement, the battery covering and associated component may need to be disposed or recycled. The recycling process for this material can be energy intensive and complex. So the key requirement for battery enclosure includes fire-resistant, corrosion-resistant, lightweight, non-conductive, easy to assemble and service, electric interference, thermal regulation. The solution for electric vehicle battery enclosure that we offer is biocomposite material, because I'm working for some time on biocomposite, has emerged as highly sustainable material aligning the requirement. We are required to work on crushing. Is the condition given to us. Has a good mechanical and thermal strength. Therefore, graphite reinforced polymer composite material can be used to replace the existing material, aluminum alloy and carbon fiber composite. Bio-based sustainable composite, natural fiber and filler, incorporating natural fiber like hemp, flax, and sustainable filler like rice husk into composite or battery casing can provide inherent flame resistance. This material can be sharp and act as insulating barriers for fire, during fire. So we choose one of the material for the metric is polylactic acid. Bio-based polymer like PLA can build sustainable composite for electric vehicle casing. Why biocomposite? The importance of biocomposite in EV. Biocomposite have excellent strength to weight ratio when reinforced with particles or fiber. This gives excellent structural integrity. This lightweight quality is crucial for electric vehicle as it contributes to the increased range and energy efficiency. And biocomposite, is by lightweight, renewable source, reduce environmental impact, and improve energy efficiency. Design challenge include lightweight design, placement of battery, smart battery enclosure, efficient cooling system, recyclable and sustainable design, and manufacturing feasibilities. The design principle in design consideration for battery enclosure, safety, thermal management, structural integrity, manufacturing efficiency. So the design principle, we look into the scarce vigilance, fire safety, thermal management, thermal insulation, cooling, heating. Of course, in the short time, we cannot cover all these things, but we only focus on the design, but this is the requirement of the design. We have a team working on this. So for design principle, the material selection to be high strength material and thermal resistant material. And we carried out the brainstorming session for the design. Brainstorming carried out, and then many brainstorming session was carried out, and the requirement for design include biodegradable, non-conductive from outside, high thermal conductivity for heat dissipation and lightweight. And this is some sketches for making the battery enclosure that we take the reference design from right hand side. That we take the idea, the initial piece of design should be simple box, handle attached, wheel attached, and compartment made. And these are the design including of the compartment, box dimension, and cell insert slot. And we presented in 3D drawing, 3D casing design, and 3D cell insert slot. So this is the 3D printing, this is some initial result that we have. This is how the batteries fit in. And then at the end we want to have 90 batteries. And of course this is the epic prototyping model, but 3D printing and manufacturing. But later on we want to have the mold, and we want to use compression molding to use PLA and graphene for the real metal able to test. So for the tapping, we want to use for battery connection copper nickel instead of bus bar. So this is the placement of the three compartment for the battery. We have 3 mold are stacked into casing, one above the other. The top compartment is reserved for controllers. The unique placement of battery mold makes the battery enclosure compartment compact in the design. So material selection, so biocomposite for battery enclosure, biodegradable polymer, we use PLA, and also we investigate the use of green epoxy, natural fiber reinforced composite, and hybrid material also being considered. We also want to have hybridization with of the graphene with nanocellulose, and consideration in material selection, mechanical properties, thermal stability, and environmental impact. So we use initially epoxy rust resin. Later on we move to PLA. So epoxy resin for most mass production, we can use the manufacturing process like resin transfer molding. This is possible. And we also investigate the green epoxy as the candidate material, and also we decided to use polylactic acid because we have the facilities, injection molding, compression molding in our lab. So these are the material we decided, but the use of the graphene nanoplate is the requirement from the funder that we should use the GNP. It's a carbon base filler that has unique properties and structure, making it ideal to be used as the reinforcement in matrix. It has outstanding properties, high surface to volume ratio, high aspect ratio, and the incorporation of graphene in polymer composite can significantly improve the physical and mechanical properties of the matrix. So this is one of the initial work that we carried out using handling up process, with GNP and green epoxy, and we use sonication and mixing, and then we have the pre-curing and post-curing, and then we have CAD drawing, and we have the 3D printing, and finally we are going for the molding, and we want to test our battery enclosure in our car. We are just halfway through in the project. So this is another material we choose on, instead of green epoxy, we use epoxy, graphene, and also epoxy, synthetic one. Same the process of fabrication and mixing, pre-curing and post-curing. We did the same thing, drawing and also 3D drawing and 3D printing. Okay, the result, this is just comparing the result of between the bio-epoxy or green epoxy with the epoxy synthetic base in terms of tensile strength is given here, and the comparison of the flexible result properties of the bio-epoxy or green epoxy with epoxy, and the hardness properties. This is just routine work we have done, the SEM. But the challenge is, the bonding between graphene nanoplate, epoxy cannot be used conveniently for mass production, as I mentioned earlier. So you can use a process like resin transfer molding for the thermoset. So we opt later on to use compression molding or injection molding and using PLA. So this is some work that we are currently doing on GNP and PLA with screw extruder to come up with the pellet, the molding compound, this molding compound, and we do the testing, and later on we do the prototype with the compression molding. We will develop the mold. So we also thinking, we have done some preliminary work on for greener solution, hybridization of graphene nanoplate with nanocellulose. We use oil pump nanocellulose with PLA. And this is some of the results using that we presented in conference last year. We have used nanocellulose and graphene. And then this is we published early this year in Polymer Composite of that work. So, ladies and gentlemen, the conclusion from my work is that design and characterization of biocomposite for electric vehicle battery enclosure represent a significant step towards sustainable mobility solution. This material offers the potential to reduce environmental impact, aligning with the push for the eco-friendly transportation. Biocomposite hold the potential to enhance electric vehicle sustainability, reduce weight, and improve energy efficiency, aligning with the industry green initiative. Biocomposite offer the opportunity to reduce the carbon footprints of electric vehicles through renewable and lightweight materials, overcoming challenges related to material development, cost competitiveness, scalability, and durability is crucial to harness the full benefit of this composite. The future direction, achieving cost competitive and scalable production while maintaining durability and the regulatory compliance remain a challenge. Lightweight materials are essential for improving EV efficiency rate, and bio-nanocomposite can offer high strength to weight ratio, potentially reducing the overall weight of EV component and vehicle. Advanced bio-nanocomposite can potentially improve the energy efficiency of EV by reducing energy losses due to weight and enhancing thermal management. Okay, I just want to share some, because I have time, so some recent publication on biocomposite. Actually, we focus more on biocomposite, but this is what is coming. People want to give us money, the industry, so we pick up, but we still want to maintain the biocomposite, meaning that green epoxy, PLA, nanocellulose, these are our main material. So that's why we have published work on nanocellulose composite in 3 different publishers. So these are, I'm showing you these 2 yesterday, but synthetic and natural nanofiber fillers in composite. And yeah, we have also published recently advanced composite aerospace engineering, and then some other book as well. This one is with NTU, the middle one. I think many of you are involved in this book. And this recent book, Chavez Composite, and other. This is what is the outcome of this research. We received this, we get this award when we complete this product in exhibition, gold medal. And this one, I think as Mr. Chairman mentioned, received this lifetime achievement award, William Johnson International Gold Medal. And this one I went to Wuhan last year to receive this award international pioneering work. Ladies and gentlemen, I would like to thank my university, Institute Putra Malaysia, for the entire research team and the entire research team for this work, NTU for the invitation to present this paper, and the Punca RM Sudan Berhad, is the one who gave us money, the funding, big funding, but I can assume a small portion of that. I was tasked to develop the electric vehicles battery enclosure. So with that, I would like to thank you for your attention. If you have any questions.
Okay, this is the professor. So we have two questions. One, two. Okay.
Thank you very much, Professor. I really enjoyed my
I think your input is new in EP and new in graphic. I am
Okay, that was the main part of my question actually.
Yeah, because you can give the opinion.
When you incorporate kind of nano scale material into the bulk material like the resin that you have utilized in your application, it is really hard and sometimes difficult to analyze the working mechanism of this nano scale materials into the bulk material and macro scale analysis. I'm not sure what you actually perform the analysis based on this incorporation of this tiny particles into
Yeah. I was given this money to this month. My colleague, approached me that, okay, please carry out the investigation on the electric vehicles with confidence giving the money. So we carried out a lot of research, the papers and review article and research paper we published, as I mentioned, on the performance of the materials, mechanical properties, thermal properties. We thought this is feasible, but we have not done until to the stage of making the component. Okay, we are now at 3D printing stage. Then the next step, we want to go to the mold maker to make the mold and try to inject. That is the scope of the work that I have to do. And then we want to test. Is there any improvement in terms of from the material or even the battery that we developed? That involve other people as well from electrical engineering. So this is quite a big project. So I was prepared just to test the material, but because of the name of the product is very specific, the electric vehicle battery enclosure. So that's why we want to try as the initial. This was initial. It's really it's initial because
the distribution of those type of materials in the body is quite crucial.
Yeah, it's
This application is kind of challenging because you have this bulk material and you want to use only 1 or 2 grams of your product.
Yeah, I understand. I really understand. I said they told me it's really initial. As long as there is some improvement. Yes.
Okay, last question. Okay.
My question is very much similar to him, but a little different from the practical or the application part. When we talk about the epoxy composites, then we have data pack about all their properties. We know what is their tensile strength, what is the mechanical strength, and what is all that impacts it. So, considering your application, you are going to use the behaviors. So, impact is a very important property.
Yeah.
And as far as these biomaterials are concerned, their impact properties are much lower than the epoxies, which is as physical literature. Another thing is that when we talk about the nanomaterials, and if we talk about the graphics, so their sizes, their layering structures, all this make a lot of difference.
Yeah.
And distribution, as Professor just said, distribution is also very important. So how you are going to get all these to make it a really feasible for the battery?
I think I will contact you. I'll contact you. I told you you're the expert.
Okay, so interesting. Okay, so the second presentation is from Professor Abraham from University. At the last, Professor Abraham is the rector of the Institute of Technology of Batam, Indonesia. head of laboratory for nanoscience and technology. He has published more than 80 international journal papers and reports, and also received top 2% of researchers with the highest paper citations. So let's welcome.
My presentation was different with Professor Sapuan, dealing with the battery material, and my object regarding the okay, I use hello. I use winter waste utilization, winter waste from CGPR official knowledge. So I'm Abra from Matalas University, Padang. Thank you very much for the to invite me as a keynote speaker here. Yeah, my field of interest is bio-based composite and cellulose for food packaging film and so on. So little bit Andalas University, my campus here on the hill, and the location in West Sumatra, near to Singapore. I think you know Singapore, Malaysia, where Prof. Sapuan is here in Malaysia. And right now I'm also a rector in private university in Batam. Only 30 minutes using ship from Singapore. This is the ITEBA private university campus. So Dr. Yasif is already there, and also Sapuan. So this is my presentation online. Background is in introduction, and also some published article, and maybe it will present using legal ways and conclusion. Yeah, why I'm interested in using or investigating or researching the waste, legal waste. Yeah, here we can see that the production of the fiber increased relatively continuously, and here we can see the global organic market in 2026 increased 7.5%. I have seen this information in this publication. So the question is how to use the mine zone bread into high value material. And in this case, I'm interested in rhizome. So the waste is not only from rhizome, but also there is from steel, steel and lead. And we know that the value-added product from this waste can become cellulose, hemicellulose, and for bioenergy. And in this case, in the presentation, I would like to present you the cellulosa become nanofiber. Here is the progress in until 2022. One of my publication was there. Our publication related to the digital fiber already published in Floyd. We have collaborated with Professor Sapuan. Because I have limited equipment, I just prepare the sample and the characterization, just send my sample to Professor Sapuan. For example, to detect the tensile strength, the SEM, and etc. As I told you that I want to develop the transparent biofilm from medium nanofiber. How to become transparent? This is because there is a nanopore in this film. Here you can see that the SEM, scanning electron microscope micrographs. If we see the nanopore here after transmutation. Without transmutation, the background on the suspensions opaque, that we cannot see the background behind the suspension. And after transmutation, the suspension become more transparent. And after drying, we have quite different appearance of the film, and not transparent and transparent film. And why? Because the light can pass through the film, and this is the nanopore in this film after ultrasonation. The fiber is now or become cellulose nanocrystal. Here we can see the fiber distribution for the film under 100 nanometer. And before ultrasonation, the fiber is still long, and after ultrasonication, it becomes shorter. So the transparent biofilm has also antimicrobial activity, excellent antimicrobial activity. Here we can see that we have tested 1, 2, 3, 4, 5 kind of microorganism, and the film show the diameter of inhibition against microorganism. And interesting is that if we hit the film still high antimicrobial resistant. We see that without hitting, we know that the film has high antimicrobial resistance, and after hitting with high temperature, 150, already published in the carbohydrate polymer with high factor. And diameter on division zone can be seen, still can be seen in this barrel. We heat 30 until 120 minutes. And this pellet can be used, has good potential for transparent and antimicrobial based mask in skincare. Yeah, because it has a good antimicrobial activity. And the next 10 minutes, 5 minutes. The second article is we develop bio-nanocomposite using ginger nanofiber, and this is very simple, just mixing with the ginger nanofiber in order to use the waste ginger fiber, and the fiber is still transparent, even though mixing with nano fiber, and the tensile strength increase with increasing fiber content, and the elongation and break will also increase because the crack part through 10,000, and moisture absorption decrease because the good hydrogen bonding between fiber and the polyvinyl alcohol, and also water vapor permeability become better. And this is the you can see why the tensile strength increase. We see that here the crack part through tortuously, so without fiber, crack can pass through directly. And after addition the fiber, the composite has a good antimicrobial activity. Now I will try to present the possibility that there is a topic, maybe the ginger fiber can be mixed with tannin. Here I want to show you which are gambia, because we have a lot of this plant, and also in essential oil and so on. Here we have this extracted gambia in our campus, in our country, and we can mix ginger nanofiber with this one. And what interesting is, because this film has a good anti-UV activities, less than 400 nanometer. But the problem is the strength is still low and moisture absorption still high. And if we mix with fiber, the ginger fiber, the properties can become better. Here, thermal properties become higher after mixing with Puncaria gambia, and become higher again if we mix with cellulose. And we can use for the sunglass and also for the food packaging. Okay, conclusion. There is a lot scope of research on the ginger, waste pellet, as I told you, for packaging and also for biomaterial engineering. And special thanks to the organizing committee. Thank you very much.
So only one question. Only one question.
Okay. Thank you very much, Professor, for that. Actually, it was interesting to utilize those type of waste material in the facial appearance, for instance. But the question is, have you ever performed the statistical analysis on your sample that you have performed? Statistical analysis. Yes. How many samples you have tested? Because the result was quite similar to each other, and I cannot see any meaningful
Question. I have only 3 samples here. Maybe we can make more than. Why not?
Okay, so our third presentation is from Dr. Eric Bashir from NESCOM. Dr. Eric is a director, and his interest is organic material and textile structures. So let's welcome Dr. Eric.
Studying the effects of geometric arrangement for 2D of woven jacket and studying their mechanical processes. The contents will be introduction to the object materials, what they are, their mechanism, their applications, objective of the study, experimental setups, characterization, and then the conclusion and the future study. So, what are the organic materials? Organic materials are the structures that activate negative isolation. It means that when we stretch them negatively, they expand in the reverse direction, actually, and vice versa. See the mechanism. When we put them out, they expand in that negative direction. So the copper then placed in the American is the best example of that. When we inhale, they expand, and when we exhale, they contract. This is another example of the auxiliary material for the fabrics. Auxiliary materials can be natural as well as synthetic. The natural, some of the natural auxiliary examples are biological tissues, cat skin, cow, pig skin, etc. And these are some examples of the synthetic auxiliary materials, the foam, honeycomb, the polymer, and textile fibers. So we will focus on the textile fibers in yarn. This is the mechanism of the auxiliary material. We can see here, this is one more example for these auxiliary materials. This is the behavior of the normal material, non-auxiliary, and this is the behavior of the auxiliary material. You can see the difference between them. When we pull them out, they stretch and they expand, and when we will push them inside, they contract. Some examples or some applications of the auxiliary materials are the auxiliary nails. When we pull them out, they get fatter and restrict the pulling out mechanism. This is the densification of the auxiliary material, and this is the major benefit in our respect that when we compress them, the materials come narrower, and this is a bounce back or reaction is observed by this material. These of shape adoption is another application of this. This is auxiliary for furniture. Auxiliary materials can be obtained from two methodologies. The one is fiber processing, and the other one is yarn fabrication. We focus on the yarn fabrication. These are some mechanisms to how to get the auxiliary yarn fabrication used by the researchers.
And this is the organic amplification mechanism. When we pull them out, the initial diameter expands, and furthermore, on application of further extension load, it contracts. These are the materials used in our study. PU elastomeric will be used as core core material. Polyester cord will also be used as a core material for comparison purposes. The PET and UHNP dyneema will be used as a wrap material. So we have to develop stable organic yarn structures using a novel braiding technology. And then we will develop fabric structures with variable geometries like mat and braid. This is the equipment used to obtain the organic yarn. Okay. This is how to make the braided organic yarn. This is the equipment used in our processing techniques. This is the forced displacement of the individual yarns. You can see here. More force, force of the UHNPE, and less displacement of the UHNPE and more displacement of the core polyester or PU elastomeric. Different properties will be combined to get the organic yarn. So, wrap angle measurement. You can see that we use a combination of 9 degree, 11, 13, 17 for both kind of core and wrap material, using one polyester cord with UHNP, and the other one was a PU elastomer cord using UHNP and PET. These are the samples. You can see the results in that. This is the Poisson ratio, meaning that organicity we obtain. We can see that this is a class A sample. This class A sample is this one, polyester cord, and the class B sample are the elastomeric. So for class A, we got about maximum organicity of -1 or 1.96 or 0.98, like that, 0.98. And for class B, we got the maximum organicity at -1.7. So PU using the PU elastomer, depending on the material inherent properties, we see that we get more elastic organic properties for the class B combination. This is a simple comparison again. Now we will focus on the more organic samples of the PU elastomeric force, and we will use this in the fabric so that we can get more organic fabric. These are some kinds of common fabrics. We have selected 3-1 print and 2 mat designs. This is the machine to Adobe Loom used to fabricate the fabric. This is the fabric left and comparison left and wrong directions. This fabric tensile testing. You see that for the mat direction, for the mat design, we got more force as compared to the twill design. Because the geometry plays an important role. More extension in twill design because of less restrictions offered by the operator in twill design. And this is the, we can see this is the comparison for the matte and twill design in web direction. So another one is another test we performed was the authenticity test, out of plane and to the thickness and in plane. These are machines used, inside test used for the out of plane authenticity. These are the values we got. Almost 5 was got for the twill warp. Warp and web direction, and that produces less authenticity, -2 and -2.61, etc. This is a comparison for the two types of fabrics in the matte and warp and in the warp direction. Now coming to the in-plane, I will not play this video because it will take time. These are the, this is a comparison of the point ratio for the matte and twill in the warp direction and for the matte and twill in the web direction. We see for the twill we got more authenticity. Twill woven fabric exhibited maximum value in the in-plane negative isolation of -1. Because having higher floats, lower crossover points, faced lower resistance offered by the auxiliary yarn present in the web direction. Matte fabrics faced the resistance and mobility caused by the frictional forces at the yarn crossover points of auxiliary yarn in the web direction, thus exhibited lower NPR. This is a velocity test. This is the mechanism used for the impact test. This is a video, again I will skip it short on the time. These are the points we got after firing, after the gunshot. We see this one is a matte sample, this is the twill samples. This is the energy comparison or energy absorption test. We see the energy value, energy absorbed by the twill fabric was 1.3 and the matte fabric resisted 3.3. So more energy absorbance was appeared for the matte fabric. So now coming to the conclusion. Enhanced structure stability was obtained with interlacement of the yarn components from using the braiding technology. Maximum NPR for the given yarn material was achieved. Helical angle of 9. Comparison of fabrics with two designs structures revealed that the freedom of movement due to longer float lengths and less restriction offered by the auxiliary yarn, twill structure generated higher in-plane auxiliary behavior with a maximum NPR of -1 compared to the matte design. The fabric with maximum NPR of -1 for the in-plane mode was lower than out of plane maximum NPR of -5.6. Single layered matte or jacket fabric possessed superior energy absorption than twill or jacket fabric. For matte and twill it was 3.3 and for twill it was 1.38. This revealed that the NPR effect was strongly dependent on the fabric geometric structure. Tensile test of composite showed 24% higher force in matte samples compared to twill samples. So this is a future recommendation, and thanks to Yasser from NTU. They helped me in this executing my PhD in this project. Thank you so much.
And also thank you, Dr. Alter. So also only one question. Any question? Only one. Okay, so thank you again for Dr. Alter. So next presentation is from Dr. Mohammed Amrahan from National Textile University in Pakistan. Dr. Mohammed Amrahan is assistant professor and PhD in textile engineering. His topic is lightweight protective armor. So let's welcome.
My name is Dr. Mohammed Khan, and I am working as an assistant professor in the Department of Textile Engineering. And my co-presenters are Dr. Yasser and Dr. Mohammed Khan. So today's topic of the presentation is development of lightweight protective armor. These are the types of today's presentation, which include introduction, time-lapse, property, and financial analysis and reviews. As the management has started, the persons carving their hello with different kinds of armors. Parallel, there are researches done to protect themselves from these harms, like we have seen fabric, leather, gold, and steel, and now it's converted towards metal. Now what will happen when the bullet strikes the exact target? Two types of waves are produced. One is a longitudinal wave and other one is the parallel formation. And the ballistic impact velocity is greater than the 200 bullets per second. Different types of materials are used to manufacture the bullets, like lead, copper, aluminum, and different shapes like hemispherical, flat, oval, and conical. Then the bullet strikes with a textile method, there are two values. One, that the velocity is less than the ballistic limit and the relative velocity is zero. In that case, there will be no perforation of the textile fabric. Like this one, that the velocity of that particular bullet is less than the ballistic limit and the bullet was inside the fabric and the residual velocity is zero. In the second scenario, there is a perforation of the fabric, the bullet ruptures the fabric and there is a certain residual velocity of that particular bullet. Ballistic protection is the ability to a material. We are using the soft armor panels and hard armor body panels to protect ourselves from different types of bullets. And ballistic protection is the protection against any type of bullet which speed ranges from 300 to 868 meters per second. These are the testing standards which are used for the testing of these developed samples against eco level testing and against NHA level 3A, in which the bullet speeds are 710 meters per second, 940 meters per second, and 800 meters per second. This standard eco testing level is derived from this standard NHA level 3, but it has more strict than the NHA level. Now, the exacting fabrics also we have used for the development of the SAT fabric. Exacting fabrics are those which exhibit negative Poisson ratio. When we stretch them axially, the normal material, it will contract in the lateral direction. While in case of exacting material, when we stretch them axially, they will not contract in the lateral direction, they will stand in the lateral direction. Like this one. Different types of composites are manufactured by using different polymer matrix composites like metal matrix composites and ceramic matrix composites. And all the properties of these resins or matrices are given in the table of the manufacturer. To design a perfect solution for protective armor, we have to simulate the ballistic impact so that we can get our input before manufacturing that particular fabric. We can calculate the longitudinal speed and the transversal range speed by using these equations, and also we can calculate by this equation. We have simulated the same fabric by putting all the parameters to simulate that what will happen when the bullet strikes in the fabric. The exact problem of this research was that protective armors available are heavy and expensive, so we have to get the lightweight and less expensive protective armors. Such therefore, fully regulated woven fabrics have delamination problems and poor overall problems. These problems can be solved by using the 3D woven composites, which reduces the delamination problem as well as the out-of-plane, poor out-of-plane properties, and increases the delamination resistance by 10 to 15%, damage tolerance, and we can tailor our properties with X, Y, and Z parameters. Except there was that we can further increase these properties by using the woven from exotics, shear picking tools, thermoplastic and thermoset resins, and addition of micro and nano reinforcements. We have three objectives for this research. One is to develop the exotic woven fabrics with enhanced adaptability. Second one is to develop a lightweight protective armors for energy level 3 or eco level 3. And the third one is to develop a finite element code to simulate the behavior of exotic fabrics and composites under sensing. For first objective, we have developed 14 samples with these codes to check their exoticity with different weave designs, orthogonal to the thickness, layer-to-layer to the thickness, and hybrid weave designs. We have weaved these fabrics on a CCI document and by using the section barcode sheet. and use these samples in the soft armor package. These are the designs we have used to develop these 14 samples with these codes. And we have checked the verticity on the UPM machine, and we have found that sample B1 with design code X404 had showed the maximum of verticity. In the graphical representation, we can see the highest negative poison ratio is shown by the sample X404, and the same sample shows the highest impact strength against carbon. This one. For development of lighter protective armors for NTU, we have adopted 2 steps. First one is to select the matrix, and then we have developed the rest by utilizing the previous step. We have used different types of resins to manufacture the components which is vinyl ester, PVD, phenolic, and their blends, and their properties are shown in the given table. We have checked against the droplet impact and found that the sample M2 showed maximum impact energy absorbed and less diameter of that filament, as shown in the figure. The depth of the diameter is less as compared to the other samples. And we can also see that this sample M2, which is vinyl PVD, has absorbed maximum energy as compared to the other samples. In droplet effect, we can see that force versus displacement curve shows that the sample M2 has real maximum force, that is 9,523 newtons. Also, if we can see energy versus displacement curve, the sample has absorbed maximum energy 6.78 joules. In charcoal test, we can see the bending and delamination of the layers during the testing, and we can see that the sample M2 has absorbed maximum energy, that is 73.65. These are the frequent bending result test in which we can see that structural strength and structural modulus also are higher in case of the sample M2, and the lamination of the layers are shown, which shows that it absorbs maximum energy by delaminating the fabric. After selection of the matrix, we have chosen the best sample from the objective fabrics and best matrix from previous experimentation, and fabricated the composite by using the compression molding and using the PVD resin and the parameter fabric by using the 12 parameters. After that, we have molded the ceramic tiles on the composite, and as well as we have cutted and stitched the fabric for carrier bag. Testing of the samples was done of the hat, and the sample graphic after striking the border shows that there is no perforation, and the trauma was also under 30 mm, which is acceptable. This is the setup where we have done the testing of these samples. After initial development, we have tested these samples here. This is the bullet striking with the target. Actually, this is the actual video of the testing. During fragmentations are passing and energy is absorbed. These are the pictures of the samples. And last objective was simulation, in which we use these parameters and simulated that how the bullet strikes with the impact and the behavior of the fabric. Here it shows the perforation and trauma on the back side and delamination of the fabric, which absorbs the energy. On the top side also, this is the propagation of the energy towards all the directions, and delamination here. This is the back side, that how much trauma shown by We have displayed these samples in different exhibitions like ideas and different types of textiles, different exhibitions. These are the cost and weight comparisons. The sample shows the maximum negative violation that is -1.62 and negative absorption is higher, carbon lines and matrix, thermoplastic matrix shows higher negative absorption while the weight is less and cost is also less in non-electric chambers. And finite element analysis also validated the results, same results which we have done in the experiment. These are the different elements and techniques with different security agencies to commercialize these samples. Thanks.
Okay, thank you. Also about this.
We have a very nice talk. We have two questions. One, how much the weight is reduced in case of
It is 4 to 10%.
4 to 10? Because normally in the domestic industry, now they are using ultra high
Microwave quality.
polyethylene.
Yes.
But your research is mainly focused on that one.
On parameter. On parameter and 3D exotic mobile fabrics.
And you know the polyethylene is
Lighter.
lighter.
Yes.
So what is the advantage of this?
Our weight is reduced due to the exotic woven fabrics. That is more, number of layers are reduced in case of exotic fabrics, while if we use Danima, we will have to use more layers. And in case of exotic woven fabric, we will use less number of layers for the same protection level.
Yes, I understand. But in case of Danima, even then the weight is lighter. In case of the Kerala.
That can be woven also in exotic woven fabrics. We can work in future.
Okay, so next presentation is from next house on Tech Hall from National University, Textiles University. My name is Hassan Iftkhar Ahmed and I am working as lecturer in National Textile University in Hyderabad. And my topic for today's presentation is mechanical performance of fiber reinforced rubber epoxy composites for impact application. So these are my research areas. I'm working on composite materials, 3D printing, rubber tanks, smart textiles, OXTEX, additive textiles, protective textiles, and numerical molding. So these are my research contributions, and I have a number of journal publications, and 13 conference papers and book chapters, one with Dr. Sulman Saleh, and one patent, and I have supervised more than 10 projects. Yes, and research grants of 121 billion rupees. I'm a co-PhD. This is the presentation overview, and I will provide the introduction of the topic, and then with the problem statement and methodology, session, and summary of the solution. So basically, thermoset matrices are used in the composites for low velocity applications, but they are trivial in nature. So elastomers having good excellent damping properties, toughness, and impact absorption properties can be a potential application in ballistics. So the energy absorption of performance is much better as compared to the thermoset matrices. Therefore, elastomers can be a good solution for ballistics, aerospace, and automotive applications. So this is the potential application where my product can be used. So our target was to make ballistic panels. So these are the
mechanical performance based on the beam architecture. So we studied the beam architecture in the first phase, and the second problem statement was that quantitative analysis of rubber is very difficult because of its high trauma after impact and due to its very much elasticity. And thermoset is brittle and it has poor impact strength. So based on these problem statements, we devised 3 research objectives. And in the first thing, we optimized the woven fabric. In second, we developed the rubber. And in the third phase, we developed the stacking sequence. We changed the stacking sequence of the rubber epoxy composite and studied the mechanical performance. So we studied the flexible composites as well as stiff composites. In flexible composites, we did not use the epoxy. And so these are the flexible composite stacking sequence. We studied this with the jute layers, and we used the summer bond as the intermediate layer. So these are the individual component weights of the flexible jute rubber composites and their thickness, density, and the percentage of each jute, rubber, and bonding gum. So these were the samples we developed on the compression molding. We made the rubber layer separately in the compression molding and jute composite separately, and we bonded them. So 3 tests were performed. We performed the chart impact testing, drop weight impact testing, and bending testing according to the standards. So on the Zwick roll machine available at the National Textile University, Festival. So these are the results of the drop weight impact of the flexible composites. So from these results, we can conclude that jute has the highest energy absorption, less peak force, and more contact time. And low energy is transferred back to the impactor in case of jute composite. And flexible composites can bear more impact of higher energy levels. This composite has no damage, so we can conclude that they can bear more impact. So these were tested at 15 joule energy. So adding the rubber layer slightly increases the peak force. Moreover, using 2 rubber layers results in delay in the appearance of the peak force, and the rebound velocity is more in case of jute composite. And this concludes that jute is more plastic. So these are the Chapi impact results. So I will skip that. So these are the summary of the impact properties of flexible jute composites in which no epoxy was used. So the specific energy absorption can clearly show the results of the elastic energy absorbed and the impact energy absorbed. So these are the stiff composites in different stacking sequence. So these are the individual component weights of the stiff composites. And these are the drop weight impact test of stiff composites. As you can see that rubber jute epoxy jute rubber composite results in maximum peak force and highest energy absorption ratio. So as you can see, there is a delay in the peak force, appearance of the peak force due to the addition of the rubber layer. And jute epoxy composite have higher energy absorption as compared to the single layer jute epoxy jute composite. So these are the chart impact tests, as you can see, in which rubber layer is used. So there is a delay in the impact force. These three are for the. Sorry, can you please? Okay, so these are for the jute epoxy composite, and these is which rubber layer were used. So these are the summary of the stiff composites, the damage type, the weird, and the specific energy absorption they are weird. So we also calculate the coefficient of restitution. So let me tell you what is coefficient of restitution. So if the coefficient of restitution is equal to 0, it means that the nature of the impact is purely elastic. And if it is equal to 1, it means it is elastic. So we calculate the coefficient of restitution for all these samples. And these are the energy loss percentages of all these samples. And the depth of the damage. These are the depth of the damage of total of the stiff composites, and these are the depth of damage of the flexible composites. So this shows that impactor bounces back more when it contacts with the flexible jute composite, because there is more energy remaining after the impact than there is for the other stacking sequence. So due to this, rubber composite absorbs less amount of energy and offers less damage resistance than other stacking sequence studied. More energy is lost and transferred to the composite in stiff composites. These are the bending results. So as you can see, the stiff composites have higher stiffness and the rubber composites have less stiffness. So these are the summary of the results. It is important to note that suggested flexible composites do not have delamination and cracks. And the primary cause of failure is, which is the primary cause of failure in the stiff composites. Therefore, it can be suggested that flexible composites have higher delamination resistance. So, moreover, the flexible composites has more elastic energy, indicating a higher rebound of the impactor in the flexible composite as compared to stiff composite. The peak force is higher in case of stiff composite as compared to the flexible composites. So we also developed the ballistic panels using the rubber layers in different stacking sequence. So these are the Pakistan standards, and these are the NIJ level standards. So these we tested using AK-47 and NIJ level 3A. So as you can see, there is a 78.9% decrease in the use of rubber layers. So we tested here that the trauma to weight ratio in the case of the weight is increased, but the trauma to back phase in nature is very much reduced in case of rubber composites. So these are the unique drawing of the HAP, and this is the model we developed in the numerical simulation, and this is we did the impact testing in ANSYS version. Thank you very much. If you have any questions.
Also, one question.
Which type of rubber you selected for your studies?
We used a high toughness rubber, which is carboxylated nitrile rubber. And we use the carbon fillers, which is the low cost fillers for the test.
So what thickness ratio of the noise for such are given these units?
We change the stacking sequence, we use similar one thickness, and we change the stacking sequence of the rubber layer. Sometimes we use it on the top of the thing, and sometimes in between. So 2.7. So we sometimes use two rubber layers together because of the limitation of the board.
So you use some of bond only or some
We try different adhesives, and I can share the results. Thank you.
Okay, thank you. So next presentation is also from National Textile University. From Ms. April up to Rashid. Her topic is electrically conductive epoxy composite fabrication and characterization for electronic applications. So welcome.
My name is Iqra Bashir. I am lecturer at Department of Textiles, Textiles University. I am grateful to the organization committee for this conference providing me this opportunity. The title of my presentation is Electrically Conductive Epoxy Polyaniline Composite Fabrication and Characterization for Electronic Applications. These are the content of my presentation: introduction of EMI shielding and conducting polymers, then schematic of conductive composite preparation, conductivity measurement, particle size analysis, EMI shielding, IR shielding, and scanning electron microscopy. This study reports on the electrical conductivity, dielectric, and electromagnetic interference shielding properties of conductive epoxy polyaniline composite containing various concentrations. The prepared composites were used as a potential candidate for conductive coatings, EMI shielding purposes, and electronic applications. The rapid use of telecommunication and electronic systems, EMI and RAM materials or coatings have been used to eliminate electromagnetic interference. Electromagnetic interference shielding materials are of great interest not only concerning shielding but also have different applications in military and aerospace. The EMI shielding materials were first used as radar absorbing materials in military applications known as stealth technology. What is EMI shielding? Electromagnetic interference refers to undesired noise or interference that an external source introduces into an electrical circuit or channel. EMI shielding acts as a barrier between the device and electromagnetic radiation. It also goes by the name of radio frequency interference. Electronics may perform erratically, break down, or stop functioning altogether as a result of EMI. EMI may result from both natural and man-made sources. To make intrinsic EMI shielding composites, conducting polymers are required. For this purpose, we can use graphene oxide, carbon nanotubes, and intrinsically conducting polymers. For this research work, we have used intrinsically conductive polymers, polyaniline, polyethylene, and polypyrrole. For this specific research work, we will use polyaniline. This is a conducting polymer which have good environmental stability and simple method of synthesis, good absorbing ability. But for industrial applications, it has low processability and poor mechanical properties. Intrinsically conducting polymers are commonly in their immeltyne base form and shows non-conducting behavior. To convert them into conducting form and into their immeltyne salt form, we can use some doping materials which convert them from their base form to their salt form. Most commonly used protonating agents are the disilbenzene sulfonic acid, phosphoric acid diesters, formic acid, and phosphonic acids. Next, we have the schematic of conductive composite preparation. First of all, for the preparation of polyaniline, we made a solution of aniline and DBSA in toluene, and the solution was placed in an ice bath with overhead mechanical stirrer. ABS solution was added dropwise, and the whole mixture was maintained for at least 6 hours for the complete polymerization. The polymerized mixture was then dried in an oven, and the dried particles with different ratios, polyaniline in ratios 0, 0, 10, 15, 20, and 30 weight% were added into epoxy resin. Following the sonigation process. For the homogenization process, then we add hardener and pour our resin into the mold. Then we cure the whole process at room temperature for 24 hours and post cure at 20 degrees Celsius for at least 4 hours. Next, we have the particle size analysis. The particle size of polyaniline particles was determined by zeta sizer using a 0.5 weight% solution of polyaniline particles in bottle. The average particle size was found to be 130 nanometer. For conductivity measurement, we used 4 probe station with tungsten metal probe 26 mm long, 45 cone angle, 25 micron tip radius, and 1 mm spacing between each probe was used. An electric current was applied between the external terminals, and a voltage is measured between the 2 internal terminals. The conductivity of epoxy pani composites increased with the increased weight% of pani. The figure is plotted between weight% of polyaniline and log of conductivity value. The curve shows that at 0, 0 weight% of polyaniline, epoxy shows insulating behavior. At 10 weight% of polyaniline, the composite shows a low conductivity value of 3.36 into 10 raised to power minus 11 Siemens per centimeter. which is due to the low levels of protonation of polyaniline and the formation of semi-crystalline plates. With the increased weight percent of polyaniline in epoxy, conductivity becomes increased, which is due to the increased concentration of charge carrier and the formation of conducting networks, which are formed between epoxy and polyaniline. Maximum conductivity was observed at high concentration of about 38% of polyaniline, which was 10 raised to power minus 3 Siemens per centimeter. All the conductivity values are mentioned in the table. Next we have EMI shielding. Electromagnetic interference shielding term is described as a logarithmic ratio of incoming and transmitting energy of electromagnetic waves explained in the equation below. Static parameters were obtained from the vector network analyzer. A schematic representation of how vector network analyzer works and how S parameters were observed is shown in the figure. S11 is the input reflection coefficient, S21 is the forward transmission, S12 is the reverse transmission, and S22 is the output reflect transmission. Scattering parameters are also called S parameters. Next we have SEA, SER and SCT, which are shielding effectiveness absorbance, shielding effectiveness reflection, and SCT is the total shielding effectiveness of the material. From the graph A, B and C, we can show graph A shows the shielding effectiveness absorbance, graph B shows shielding effectiveness transmitted reflection, and graph C shows the total shielding effectiveness of the conducting composites. Polyaniline is electrically conductive and EM waves are reflected from the electrically conductive surface. Polyaniline particles dispersed inside the film and some particles were retained on the surface of the composite. Particles that were present on the surface gave higher shielding effectiveness reflection, but the particles inside the film gave the shielding effectiveness absorbance value. Pure epoxy has no electrical conductivity and magnetic property, so it is completely transferred to the EMI waves. Figure ABC shows the EMI shielding effectiveness values of all the prepared samples. Next we have IR shielding. 95% transmittance was observed in the NIR region, indicating almost full transparency of NIR radiation to pure epoxy. As polyaniline is added in epoxy, transmittance drops to 5% with only 10% of polyaniline. Next we have scanning electron microscopy. As you can see from the figure A, at low weight percent of polyaniline, about 15 weight percent, the particles are completely and homogeneously mixed with the epoxy resin. But at 20 weight percent concentration, they show some agglomerates formation in the epoxy resin. But when we check the cross section of the 20 weight percent of polyaniline, we can clearly see that all the particles are homogeneously mixed with the epoxy resin, which gives the good conductive properties and EMI shielding. By increasing the polyaniline content in composites, the conductivity increased, and at 38% of polyaniline, the composite has a high conductivity value of about 10 raised to power minus 3 Siemens per centimeter. Less than 0.5% transmission of NIR waves was achieved in the whole NIR region, and shielding effectiveness of 63 decibel was observed in a broad range of microwave frequency region, 0.1 GHz to 20 GHz. The prepared composites are used for conductive coatings and EMI shielding purposes. Thank you.
Thank you very much for your interesting presentation. I've got one question. It has two parts. The first question is, what's the rationale behind using polyaniline inside the epoxy matrix? And have you not considered using carbon nanotubes or any kind of carbonaceous material to enhance the electrical conductivity?
I have published some other articles in which I have used some other materials like nickel, zinc barium ferrites, nickel ferrites, and some other materials in epoxy resin, or some other brands like elastomers, which are used for EMI shielding purposes. This is some of my research work from them.
Right. The reason for asking this question is, you know that you add very low amounts of carbon nanotubes, for instance, you can increase the electrical conductivity quite dramatically. And since you have added 28% polyaniline, I just want to know the rationale behind using polyaniline inside the epoxy matrix.
We have prepared polyaniline through solution polymerization method, not through in situ polymerization. So, which means if we have added 30 weight percent, which means it actually 30 weight percent. In situ polymerization, we are doubtful how aniline is converted into polyaniline and which amount is added into the material. But through solution polymerization, we are actually confirmed the value that the actual value which we have added into the material is the final value of the material.
Okay, thank you. Okay, so next presentation is from Ms. Aisha Abdul from NTU. And the topic is for multifunctional carbon reinforced polymer composites incorporated with inorganic frame retardants. So welcome.
Thank you for this platform. Thank you for organizing committee of the International Conference on Knowledge-Based Textiles. I am presenting development and characterization of multifunctional carbon fiber reinforced polymer composites incorporated with inorganic flame retardants. Here are the contents. Firstly, the introduction of the topic, then the formulation of flame retardant reinforced epoxy and its characterization. Afterwards, the composite fabrication and its characterization conclusions. In the composite, usually, the reinforcement provides the high mechanical properties and the material providing high resistance to heat, chemicals, and moisture. However, the inflammability of the material restricts the use of composites in the field of flame retardants. So therefore, we use such composites, restrict the use of such composites in the field of flame retardants. When a polymer material catches fire, its covalent bond breaks and this breakage continues during the burning process until the structure is destroyed. To prevent or minimize the damage, the flame retardant can be reduced into the matrix, which is usually epoxy resin. The flame retardants are of two types, reactive types and reactive types. Reactive type flame retardants can be introduced via reaction with the backbone chain of the epoxy resin, and additive types are just added into the flame retardant as a blend. Flame retardants are compounds that can be added to materials such as plastics, coatings, epoxies, textiles, surface materials. Flame retardants work on four basic mechanisms: the gas phase radical quenching, the lesion of gas phase, thermal shielding, and endothermic degradation. Gas phase radical quenching is to suppress or halt the propagation of highly reactive flame retardants such as radicals. These radicals are responsible for the combustion process. By quenching these radicals, the chain reaction that sustains the flame is disrupted. In the diffusion of gas phase reaction involves reducing the concentration of oxygen, which act as a fuel in the flame retardant process, and these combustible gases are removed and replaced by nitrogen or some other carbon dioxide type gases. In the thermal shielding, the material protects the heat exposure and prevent the ignition or combustion. It involves the incorporating materials or coating with a high thermal resistance into the structure of a material and absorbs and dissipates and reflects the radiation away from the protected material. Endothermic degradation material undergoes a chemical reaction that absorbs the heat with surroundings and thereby lowering the temperature of the heat of the material. We use magnesium hydroxide and potash alum, which are magnesium hydroxide usually forms the oxide layer, cools down the polymer surface, dilute the burnable gases and are non-toxic, while the potash alum is environment friendly, reduces chars and becomes fluffy upon the production of during the combustion process. a systematic method, like increase the quantity or concentration of potassium gradually while decreasing the concentration of magnesium hydroxide gas. In the first sample, we have no flame retardant, the pure epoxy sample, then we have 28% of magnesium, then we have 15% of magnesium with potassium as 5%, then magnesium and potassium in equal concentration, then we increase the concentration of potassium and decrease the concentration of magnesium hydroxide, and at the end, we use only potassium as a flame retardant in oxygenase. We did characterization like the 94 burning tests, so vertical burning test, then thermal analysis for tar residue, and then vector analysis for mechanical properties. Then we did optical and SEM analysis for the composite of carbon fiber reinforcement. Here are the results. The figure shows different samples before burning, and the second figure shows the residues of sample after burning. Basically, the dual 94 burning ratings are categorized in three categories: B0, B1, and B2. B0s are for the self-extinguishing material that self-extinguish within the 10 seconds without dripping. B1 is self-extinguished within the 30 seconds without dripping, while B2s are the self-extinguishing materials that extinguish after 30 seconds with dripping. Also, if the sample drips and does not extinguish, it is rated as no rating, which is NR, abbreviated as NR. So we can see that epoxy without any flame retardant, complete deterioration of the structure. Also due to burning, excessive dripping was also observed. In both samples rated as B2, B and C sample, both dripped excessively and does not stop burning before 30 seconds. So that is why we rated it as B0. While B1 samples, B1 rated samples have no dripping and stop before 30 seconds. As we can see that B0, the potassium sample showed the high flame retardancy estimated 4 to 10 seconds. The magnesium hydroxide is smoke suppressing material and the burning factors of without any dripping and smoke formation, while potassium reduces char and it takes the fire triangle. Then we have TG analysis, thermodynamic analysis. The thermal properties of all formulations are compared at two different temperatures. The first temperature is 5.8% loss, and the second is at 600 degrees. The 100% epoxy sample shows the broad thermal decomposition flat in a range of 0 to 276 degrees at the 3 to 8% mass loss, while the other shows the later stage. The addition of flame retardant seals the sample by burning itself first and suppressing the smoke and the fire. They often come out of a material when exposed to flame to protect the matrix. Then we have the flexural properties. As we can see that the flexural strength and modulus gradually decreases while increasing the concentration of flame retardant. So it is to be said that it should be wisely used. When we are using flame retardants as an additive, we have to use them wisely, as the higher concentration will lower the mechanical properties of composite. The composite was fabricated with resin infusion technology and hand-layout method. Both methods were compared at the end. The resin infusion technology could be better used because of vacuum bagging, which does not allow the air and the bubble to fragment. In the figure, showed the lift setup. Here is the images of comparison of both hand layup and lift methods. We can see the whites in the hand layup method, in the hand layup samples, and there is no entrapment of air or any bubbles in the lifting method. Then we fabricated composite of carbon fiber reinforced composite. We did in-plane shear test. These are the results. We can see that the presence of flame retardant additive, the mechanical properties drastically decreased, and the delamination pattern was DTG, which is mean that delamination from the top of the gauge length, which shows the weak mechanical properties, while the epoxy sample, which had no flame retardants, was delaminated from the middle of the sample after getting so much stress. Then we did EQ94 test again for the carbon fiber reinforced composites, and we can see that the structure is sustained after burning. This is because the presence of carbon fiber reinforcement. because the matrix has the same quantity of flame retardant in them, and the carbon reinforcement imparted the structure stability. Here is the post-fracture optical analysis of the carbon fiber reinforced flame retardant composite. We can see that the magnesium hydroxide has smaller voids as compared to the potassium larger voids. Then we have a SAM analysis. Post-fracture SAM analysis of magnesium hydroxide was done. The SAM analysis of carbon fiber reinforced composite of having potassium was not analyzed by the SAM because it has larger voids and cannot be seen in the SAM images. So, we conclude that the results show the V0 rating of potassium and at the end charge yield was 71%, while magnesium hydroxide exhibited better mechanical properties, but over 94 ratings were V2 ratings. And the carbon fiber reinforced with potassium with 2 white graphs showed the low mechanical properties as compared to the magnesium properties. And the thermogravimetric analysis also shows that the presence of potassium increased the charge yield as compared to magnesium. It was concluded that the carbon fiber reinforced composite with potassium was better in comparison to flame retardant properties, while magnesium was better for the mechanical properties. There are the references. Thank you so much.
So also one question.
Thank you very much for your very interesting presentation. I've got a question related to your TGA results. You have shown that you have been to, I think, around 700 degrees Celsius. If you can go back to the slide, please. Yes. So I've got basically 2 questions. The first question is, under what conditions have you done TGA?
In normal atmosphere, it was nitrogenous atmosphere.
It was nitrogen or air?
Air.
Okay. The degradation temperature for epoxy is around 200 degrees Celsius, and at around 500 degrees Celsius, it completely degrades. So you have been to 700 degrees Celsius. How would you explain the results over there?
In my experience, I have seen that epoxy undergo degradation around 440 to 600 degrees.
Still, you are at 700 degrees Celsius, and the mass loss I can see is around.
It is complete combustion.
Sorry?
The end points are the complete combustion. After combustion.
But still,
it is just char. It is just char residues.
Right. Okay.
Epoxy has been degraded to 440.
Okay.
But this after 440 to 600 degrees centigrade is the char residue.
All right. Thank you.
Maybe did you use your flame retardants as such, or you see and selected a particular particle size, because you are observing delamination in your composites. So this
we
is
did
the
see
effect of
we did see the analyzer, and we were in the micro to nano stage. I didn't include it in this slide, but it was after Baldwin, we achieved the nano and micro size of potassium.
you found all milling size reduction. Okay. So you represented these results with nano size materials or micro size materials?
Nano size potassium, because when we are doing predicting, the micro size particles does not go inside the layers of the carbon fiber. They agglomerate before carbon fiber. So that is why we use nanoscales.
Okay, so much more questions. Okay, thank you. So the last presentation is from Mr. Suhail Arif, also from National Textile University. So, most welcome.
like you can see in the figure, the inner part of the material is the lightweight liquid and the outer part are the thin skins. So if we talk about the significance of this sandwich composites are preferred choice when lightweight, high energy absorption, less worthiness, noise reduction, improves regular performance is required. And the train, while the application of the sandwich composites are train compartment, cruise ship cabin, building insulation, impact absorber in automotive, aircraft and aerospace industry. These are the parts of honeycomb core structure. Like you can see, there are two parts of the polymer honeycomb core sandwich. One is base sheet and other is core. The properties of honeycomb cores are low strength, high bending, low density, while the material used to manufacture polymer honeycomb core are solid, expanded form, honeycomb structure, and face sheet. The properties of face sheet are thin, stiff, and strong material, while material like metal or plywood, reinforced plastics and cardboard are used in face sheet. Honeycomb structure, here you can see there are different types of honeycomb structures used in daily life, like aluminium honeycomb, Nomex honeycomb, thermoplastic honeycomb, stainless steel honeycomb, paper coagulated board, honeycomb board. The application of these honeycombs are used in aerospace, automotive, sports industry, furniture, and packaging industry. Techniques of honeycomb core manufacturing are explained here. First of all, expansion and adhesive bonding. In this method of manufacturing involves stashing of sheet materials like aluminum or Nomex paper into honeycomb structure via corrugation or other forming methods. And these sheets or Nomex paper are joined by adhesive. Limitation of this technique is limited material option, variation in cell size and shape. Other technique is in situ forming. In this, the process of making honeycomb core manufacturing is liquid substance like resin or metal in situ within a mold to create honeycomb structures. The forming process can be accomplished through chemical reactions, physical expansion, etc. Limitation of this process complexity, limited material options. Other technique is extrusion molding. In this method of manufacturing, honeycomb cores manufacturing can be extruded directly from materials like plastic or metals. And if we talk about the limitation of this material, this technique is limited material option, complexity, and cost. Then the other two manufacturing techniques are injection molding and powder metallurgy. Limitation of injection molding are limited mold option, complexity, and cost, while the powder metallurgy, the limitation of powder metallurgy techniques are high cost, limited to metallic materials. So, what is additive manufacturing? Additive manufacturing Gap et al. Found the basic comparison between circular honeycombs, hexagonal honeycombs, triangular honeycombs. The conclusion of this research that inverse relation between strength and strain recovery in the case of circular honeycomb structure, hexagonal honeycomb structure, and triangular honeycomb structure. Bears et al. Found that when honeycomb cells are compressed in the radial direction, they buckle and deform at 10%. In the contrast and transverse compression causes cell walls to bend but not buckle. XU Brand et al. Found that 3D printing can make things with more geometric complexity using layer by layer deposition. Due to their light rate, frequency response, tunability, and manufacturability, variable density circuit structures are interesting possibilities. Commercially available honeycomb structures are made by using expansion and adhesive bonding, insect forming, powder metallurgy, extrusion molding, and injection molding techniques, which requires limited material options, complexity, and high capital investment, and are limited to specific die shape for different structural design. While 3D printing of honeycomb structure is an alternate approach, which is simple process, different materials require less capital cost to produce prototypes and working structures. The research aim of this research was to fabricate a honeycomb core using 3D printing and produce a reliable sandwich composite. The objective of my research was to fabricate polymer-based honeycomb core with different cell sizes. The next one is to investigate the influence of honeycomb cell sizes on the impact behavior of honeycomb sandwich structure. Material like research was clearly glass fabric, epoxy resin. Potential benefit for industry and society was in the increased fabrication of honeycomb structure, post-practice solution compared to in-practice industrial process for honeycomb. Finding for the effect of honeycomb cell size on fracture behavior of sandwich composite. They can use sports, defense, railways, locomotive, automotive, aerospace industry. This is the design experiment of my research. There you can see the 4 factors: cell density, cell diameter percentage, increase in cell facing streams, and 3 levels like cell density, high, medium, low, cell diameter 10, 16, 25 percentage increase, and facing stream level GFRP and PLA. So density changes, increasing the hexagonal cell size by 37%, decrease the density by 20%. 60% increase in cell size resulted 40% reduction in density. Experimental work CAD file was designed, then this file converted to SQL file, slicing layer, then FDM process using 3D printing, then honeycomb core manufacturing, then phase sheet fabrication by glass, then by PLA, and the last combine this phase sheet and core to make sandwich composite. Testing performed in this research work was compression testing, 3-point binding testing, jargon back testing. You can see the figure of the equipment like WES 100, hydraulic universal test machine, and pendulum tester. Here are the results and compression molding. Compression test results. Short cell size honeycomb core shows the maximum compressive strength, maximum ultimate force like 45.29 kilonewton, and strength is 452.9. So the Flagellar test results if we talk about short cell size honeycomb core with glass reinforced face sheet shows a maximum maximal load and flagellar modulus which is 9570 megapascal and the LHA means large cell size honeycomb core with additive manufacturing shows the best flagellar strength. Charping fact test was performed. It shows that the short cell size honeycomb core with glass reinforced polymer face sheet shows a maximum force which is 515 kilonewton and maximum impact energy 4.5 kilojoules per meter square. These are the bar charts. Also, impact test was performed with the sidewise traction and also with the So conclusion, in this study, standard structure was made by varying the core cell sizes and with varying the facing skins, glass fiber, input process and additive manufacture. It was noted that by decreasing the die of hexagonal cells in honeycomb core, the compressed strength of the honeycomb core increases. The reason was that the large number of cells increases the density of material and the absorb a large amount of compressive strength. GFR3 facing seen with short cell size honeycomb core samples shows better fragile properties and impact properties as compared to additive manufacturing facing skins due to short cell sizes and high modulus of glass fiber. Thanks.
Only one question. One question. So thank you again. So we have finished the first session this morning. So thank you. So what for presenters?
Okay, thank you so much, sir. Now I would like to call our session Professor Bong for the distribution of the certificates among the presenters. So our first presenter is Professor Mohammed Sabun Saleh. So please come on the stage. The next one is Professor Harun Abrar. The next presenter is Dr. Arif A. Shah. The next one is Dr. Mohammad Imran Khan from the National Textiles University. Next presenter is Mr. Hassan Iqbal from the National Textiles University. Next one is Ms. Ikra Abdul Rashid from the National Textiles University. So the next one is Ms. Aida Abdul from the National Textiles University. And the last presenter is Mr. Sohaib Arif from the National Textiles University. like to request Professor Diaga for the certificate to our session chair, Professor Wong. So please come in. Now I would like to request all of the presenters and the session chair for a group photo. All the presenters, please come.
Ladies and gentlemen, it's time for a short tea break. We will gather back here at 11:55. Attention please. Management team escort our guests to the tea break session. Management team.
Dr. Shiva was now
कैंसिल हो
ये ले ऐसे
भाई ये पकड़ ले
Welcome back, ladies and gentlemen. It's the time for our second keynote session of the third International Conference on Knowledge-Based Textiles, ICAD 2024. And this session will be chaired by Professor Mohammed Yahya from the University of Technology in Malaysia.
Please allow me to introduce Professor Mohammed Yahya, a distinguished expert in composite materials and structural engineering. As the director of the Center for Advanced Composite Materials at the University of Technology Malaysia, Professor Yazid brings a wealth of knowledge and experience to this field. With a PhD and a remarkable publication record, including over 190 international journal articles and significant conference presentations, rapid dynamics, and more. Notably, Professor Yasik was honored with the highest commendable paper award by Japan Impact Committee JIC 2007. Jointly, we welcome Professor Muhammad Yasik Yahya. So now I hand over the session to you.
Okay, thank you. Now, our session is B3, focus on wastewater treatment. So we have 4 presenters today for B3 group. Okay, and the first presenter is a keynote speaker, Dr. Aminuddin Haji from Yad University, Iran. Okay, please. So the title is Potential of Modified Fibers in Textile Wastewater Treatment.
First, I would like to thank the organizers of the conference for inviting me, and also I'd like to thank Dr. Lee. My presentation is about the potential of modified fibers in textile wastewater treatment. I am Aminuddin Haji from the Department of Textile Engineering of Yad University. As you know, textile industry is one of the most polluting industries among all industries. Heavy load of dyes, also heavy metals and surfactants, different kinds of surfactants are referred from textile factories that are serious issues for human health, for the environment, for aquatic life, and it is necessary to treat this kind of wastewater with proper technologies. There are different technologies for the removal of heavy metals from water, coagulation, for precipitation, ion exchange, absorption, reverse osmosis, electrophoresis, membrane filtration, and so on are among the important technologies for the removal of heavy metals from water. Also, there are various technologies for the removal of dyes from wastewater, absorption, and various kinds of solvents, and filtration, chemical decomposition by ozonation, electrodecoration, photodegradation, microbiological decoloration, and activated sludge, pure culture, and so on are among the other technologies. Among the technologies that I told in the previous slides, adsorption is one of the most frequently used methods for the removal of both heavy metals and dyes, and different kinds of adsorbents have been studied at laboratory level, also at industrial level, and natural fibers and modified textiles are two of the most important types of adsorbents. Fibrous adsorbents possess several advantages compared with other adsorbents. The most important is the large specific surface area. Also, they can be conveniently woven into different shapes, and they have low and easily controlled resistance to fibrous filters, and you can see that they can be produced in different forms. Ion exchange is a process that is involved in fibrous filter media,
has several advantages. I skip to name these advantages to save the time. Also, there are two important notes for the preparation of hazardous materials for the removal of toxic pollutants. High content of chemically active groups for absorption of the harmful pollutants is a must for fibrous textiles, for fibrous absorbents, and preserving the mechanical properties of the fibers is another must that should be considered. Different forms of textiles are produced at industrial scale for ion exchange fibrous materials. There are several companies that produce ion exchange fibers at industrial scale. For example, FIBAN ion exchange fiber is an important example. There are different types of FIBAN fibers with different active groups, different capacities. It is a sample structure of FIBAN K1 or FIBAN K4. You can see the important chemical group that absorbs the pollutants here. It is another kind of FIBAN group, FIBAN fiber, showing the most important active group in it. Vion is another company that produces ion exchange fibers, different kinds with different active groups. Ion exchange fibers from Japan is another company, and also another brand is Ion, which produces different types of fibrous materials for wastewater treatment. These were the most important commercially available absorbents, fibrous absorbents. Also, there are several researchers about this topic, and any kind of fiber, any kind of common natural fiber can be converted to absorbent, can be used as intermediate. For example, different modifications have been done on cotton fibers, cotton textiles, to produce ion exchanger fibers from cellulose-based fibers. Also, from wool, there are many studies about conversion of wool fibers into ion exchanger fibers. Here, I wrote some examples of the studies on wool fibers for production of ion exchangers. You can see the mechanism of the process, mechanism of the reaction for producing the wool fiber that contains groups that are able to chelate with metal ions. This is another example with these groups. In our group, we started to work on conversion of synthetic fibers to filter media. We have some studies on polyester, some on acrylic fibers, and some on polypropylene fibers. They are three most consumed fibers and most wasted fibers among the synthetic ones in all the world, and also in my country, Iran. For example, in one series of studies, we grafted polyester fibers with different kinds of chemicals. For example, acrylic acid, acrylamide, and 4-vinylpyridine were grafted on polyester fibers using benzyl peroxide. Also, we grafted acrylic acid and acrylic acid on polyester fibers and achieved good absorption properties. For example, here you can see that PET fibers grafted with acrylic acid has the ability to remove cotton and globium from water, and it was increasing by increasing the grafting field. Another fiber that we studied on conversion of it into ion exchanger was polyacrylic or acrylic fiber. It is used in huge amount in my country. The carpet industry is one of the famous industries in Iran, and a large amount of waste fibers are produced. So, as this conference is about the circularity, is about the recycling, one of the ideas to recycle the waste fibers is to convert them to ion exchange fibers. So acrylic fibers can be converted to this useful product by, for example, according to our studies, by reacting with hydrogen, it was able to remove different kinds of metal ions. Also, different amine compounds like diethylene triamine hydroxide, like this study, we applied hydrogen on polyacrylic fibers and produced different groups on each that showed high absorption capacity for different metal ions. Another study, cross-linking with hydrogen and treatment with hydroxylamine, hydrochloride, again different groups were created on the fibers, and it showed good capacity for removal of metal ions. This is another study. We applied tetramethylenediamine, showed high absorption capacity for heavy ions. Also, ethylenediamine showed a similar result. Other amine compounds, diethylene, also ethanolamine, all compounds showed great ability to convert acrylic fibers to gelatin fibers. This is another study. We hydrolyzed polyacrylic fibers with sodium hydroxide, then reacted with iourea, and it showed very effective properties in the removal of chromium and other ions. Also, another study we reacted acrylic fibers with citric acid and showed good ability to remove other ions as well. So we can see that acrylic fibers are good candidates for conversion to gelatin fibers, iron fibers, by reacting with different kinds of compounds, including amine compounds, citric acid, and sodium hydroxide. In other studies, we studied on polypropylene fibers. You know that polypropylene fiber is another commonly used fiber, and a great amount of waste is also produced from the polypropylene fibers used in many kind of applications, for example, as masks or others. So it is a good idea if we can convert them to other useful products like absorbents. In one of our studies, we grafted acrylic acid on polypropylene fibers using plasma. So here we didn't use initiators to start the grafting. Plasma can produce the required free radicals on the surface of the fibers. So the monomers were grafted, the polymers on the surface of the acrylic nonwoven. Also, after grafting the acrylic acid on the nonwoven, we grafted polypropylene polymer on it as well. So in the first step, we produced carboxylic groups and fibers. It was able to absorb anionic light, which contains amine compounds, amine groups. The new adsorbent was able to absorb the anionic dyes. So this adsorbent can remove both anionic and anionic compounds from water. Here we can see the surface of the fiber before quantification, after grafting of the acid and after grafting of the dendrimer. And these various studies also confirm the presence of oxygen containing groups and here the nitrogen containing groups, which afford the successful grafting. Here I show the mechanism. Phenomenon was activated by plasma, peroxide produced, created on heat, and then monomer acrylic acid was grafted on heat, polymerized on heat. Then the dendrimer, polypropylene dendrimer, which contains amine and groups, was grafted on this, and so this newly prepared adsorbent contains both CO groups and also the dendrimer has several amine groups as well. And here you can see that methyl blue was absorbed by the acrylic acid grafted polypropylene. The removal efficiency was about 75–80%. And here you can see the isotherm. Then for the acrylic acid grafted polypropylene grafted in dendrimer, it was much better for anionic dyes because you can see that even after very short time, maybe less than 5 minutes, the removal efficiency reached nearly 100%. So it was very good for very fast removal of the dye. And the isotherm conforms with the Bromwich isotherm. In another study, we grafted beta-cyclodextrin on polypropylene nonpolymer. In this study, again, we activated the surface of the polypropylene non-polymer oxygen plasma, and then we used citric acid and sodium hypophosphate to graft the beta-cyclodextrin on the surface of the fiber. So by curing an interconnected network of citric acid and beta-cyclodextrin was produced on the surface of the fiber. So here we have a large amount of carboxyl groups and also the cyclodextrins that contain cavities, that contain OH groups that have the ability to encapsulate different compounds. They have the ability to absorb compounds. So this adsorbent was a good candidate for removal of toxic materials like dyes. Here you can see the mechanism of interaction of the anionic dyes in the blue with the prepared adsorbent. For example, here we show the ionic attraction, hydrogen bonding, inclusion complex. So the dye can be absorbed and removed by the adsorbent using various strategies. We optimize the process. It can be seen that by increasing the curing time, also curing temperature, and plasma treatment time, and beta-cyclodextrin and cyclodextrin concentration, all increase the dye removal efficiency. And here you can see the SCM of the untreated, plasma treated, and grafted that by these treatments, the space between the fibers is retained intact. So the nonwoven can, the liquid can pass through the nonwoven. This process did not block space between the fibers. So this absorbent also showed good efficiency, more than 80% removal, and Froelich model and Soto-Second model for the isotope and chemicals. In another study, we functionalized the polypropylene nonwoven by plasma and cytosol. Then we applied two different nanoparticles on it as well. So, plasma treatment was employed to improve the adhesion between the polypropylene and cytosol. Cytosol has amino groups, so it is used as an absorbent alone. Here we fixed it on the fiber to improve the efficiency. So here you can see that we crafted the cytosol on the surface of polypropylene, then titanium dioxide nanoparticles were coated on its surface, and here we synthesized silver nanoparticles in situ on the surface of the titanium dioxide nanoparticles to improve their efficiency in photocatalytic activity. So, acid light was selected for this study. Here we can see that the polypropylene fibers grafted with cytosol showed good ability to remove acid dyes at acidic pH around lower than 4, and the isotherm and kinetics, isotherm was Froelich and kinetics was Soto-Second model. Then we applied titanium dioxide as well as silver nanoparticles. By applying the titanium dioxide, you can see that here is polypropylene grafted with cytosol after adding the titanium dioxide. Under new radiation, the efficiency was improved. And also by adding the silver nanoparticles, it was improved more. We didn't test it without UV under daylight, maybe because titanium dioxide shows photocatalytic activity on the UV. But by adding the silver nanoparticles, it will show this activity under visible light as well. And here you can see that by increasing the best one is using 0.5% of titanium dioxide. By increasing the concentration of titanium dioxide, the results were not improved because of the application, because maybe you do this that the nanoparticles are not more accessible for the dye output. So it was another candidate for converting the polypropylene fibers into absorbents. So in conclusion, I can say that different textile fibers, including natural fibers and synthetic ones, can be modified using different techniques to produce fibrous absorbents or ion exchangers for wastewater treatment. They usually show better removal efficiency besides faster kinetics, better regeneration, and low impact on flow rate. The large number of the relevant studies up to now confirm the high potential of textile fibers for preparation of highly efficient fibrous filter media. Waste textile fibers can be good candidates for transformation into fibrous absorbents towards sustainable recycling. Thank you very much.
Okay, thank you very much, Dr. Aminuddin, for your presentation. So we open for question and answer. Maybe 3 questions. Okay, please.
Thank you for a very nice presentation. You have definitely successfully achieved some results and the projects for this. So my question is, you have used the term functionalized fiber. You have used the term functionalized fiber. And you are reporting the absorption of pollutants, right? You're using the nanoparticle materials to functionalize, like the last time I came for one strategy is prior to Titan mobilization, the fiber which you have reported as removal efficiency, is there any approach so that you can claim it's not only the removal, it's also the degradation or mineralization of the pollutant? Because the absorption means the dye is there, you have just removed it from the system.
Yes, when we have only absorption, it is important to see the recyclability of the absorption. So if you are able to reuse the absorption, it is okay. About degradation, only the last study which we applied and particles, it degrades the dye. So on the UV radiation or maybe light radiation, we did not test it. Degradation also takes time. Yes, we did the testing. Yes, the absorbent was good. It was not. There was no large amount of. Yes. Visibly, we could see that there is no dye on the absorbent. But in other studies, the dyes can be seen. Yes, because the absorption of acrylic fiber is not high at low temperature. It is the same for polyester and also for polypropylene. It does not absorb anything. So none of these fibers can absorb the dye themselves without purification. We added only some functional groups, not the groups that can degrade. Amine groups or carboxyl groups or similar. So, there will be no degradation. Yes, they only absorb or exchange the ions.
Okay, thank you. Another 2 questions, please. Okay.
Normally, we cannot dye PP fiber.
Sorry?
Normally, we cannot dye PP fiber. No problem. Normally, we cannot dye PP fiber with exhaust method or other methods because
we cannot dye.
Yes, we can dye polyester, we can dye polyamide, but we cannot dye polypropylene. Is there any convenient method we can easily dye PP any shade with respect to our conventional dye methods?
To my knowledge, there is no way to dye the common polypropylene fiber with common methods.
Yes.
So if you want to produce polypropylene fibers to be dyeable, you should add something to it. Maybe blending with other polymers, maybe blending with some nanoparticles. We studied, for example, blending with clay, non-clay. So it improved the dyeability too much.
During the extrusion process
Yes.
of polypropylene?
Yes.
But after extrusion, after
After
the processing, you cannot dye.
We can try surface modification, but it will be surface dyeing, not penetration of the dye.
Okay.
So the surface dyeing will take effect. So you will see that the color strength is higher compared to the common fibers, but the fastness will not be good because the dyes are only on the surface. There will be no penetration inside the fiber. So all are surface modifications.
If we modify the surface of polypropylene and can we do some moldings to
No, because mordants can interact with fibers that contain some functional groups.
But fiber is now modified.
Non-modified polypropylene has no functional group. So if you apply the mordant, there will be no interaction between the mordant and the fiber.
There will be
Even
more fastness.
nothing important will take place. I'm sure that polypropylene cannot be dyed using mordants. If you alter the surface by some techniques like that I told, for example, grafting of acrylic acid, grafting of phytosanol, other techniques, the result will be good if you are considering absorption, not dyeing. Dyeing needs good fastness, but it will not have good fastness.
Thank you.
Okay, okay, that's what you said.
I have a question, Prof. This application, will this be size exclusion based or absorption based?
Sorry?
The process of separation of the dyes, will it be based on size exclusion or absorption?
Absorption.
Absorption. So can we use
Only for better cyclohexylene inclusion complex will also be effective.
I have a follow-up question. If it's an absorption, will it be able to handle both cationic or anionic dyes as well simultaneously, or only for cationic?
It depends on the active groups that you created on the fibers. In one of our studies, because we applied acrylic acid first, then grafted it with dentrimer, which was cationic. Finally, we had both groups. When reacting the dentrimer with the acrylic acid activated surface, not all groups were involved in the reaction. So some groups remained and some groups were consumed by the reaction with the dentrimer. So the adsorbent had the ability to absorb both kinds of dyes because there were both kinds of groups.
Okay, so for the case of polypropylene, how will the regeneration cycle how we can regenerate them?
By putting it in different pH. If for example, you added cationic groups, amine groups on the surface, it will show the best absorption in acidic media. But putting it in alkaline media, the dye will be dissolved. You can reuse it.
Thank you very much. Thank you.
Okay, thank you very much. Dr. Aminuddin Adi. Okay, if you have any question for this topic, maybe after this, you can discuss with Dr. Aminuddin Adi. Okay, thanks again. Okay, the next presenter is Dr. Nimrani. Please. Dr. Nimrani, the title is Harness the Power of Sun to Bring Circularity to Textile Wastewater.
Assalamualaikum. Good morning, ladies and gentlemen. I am basically a researcher in this GCF project, working on the work package 5. And today I am presenting particularly to introduce the circularity in wastewater of textile industry. Basically, the title is Harnessing the Power of Sun to bring the circularity to textile wastewater. Considering the SDGs which are available, the wastewater utilization within the textile industry, there are 7 main goals focused in the circularity of textile wastewater, which comes that it should not be hazardous to the aquatic life, it should not be hazardous to the human beings, environment safety, availability of clean drinking water. So this is what we have focused in SDGs. The textile industries, for example, the textile industries in Faisalabad. Faisalabad is known as the textile hub. The textile industries, I would like to share an experience. I have visited the 2 industries on the same day in early 2018. I was in my PhD.
One was, I would like to mention the name of one industry, that is Bulgesha Packages, which is a paper industry. They do have a very excellent system of wastewater treatment. They didn't let us know exactly what they're doing with that, but they visited us the site and they told us that all the water that is being cleaned in the industry, that is being supplied to the nearby farmers by through proper channels. And sometimes the farmers also ask them, some farmers fight them to have that water because the mineralization content is pretty high and it's good for crop yield. On the same day, we have visited another industry. I would not like to mention the name. That industry is even bigger industry, even better industry, even better treatment plant. But what the presenter told us that we have maintained the quality standards. The COD is controlled, the BOD is controlled, it is used, reusable, everything. And when I asked her, what did you do with the treated water? He said it goes directly into the mainstream. And we were shocked that you're maintaining the quality of the treated water and you're not reutilizing it, or you're not providing it to any other sector. So this is not at all a nice approach. What did the water do? What did the textile industry effluent do with the humans or aquatic life is dangerous, of course, we know. Dr. Abhiruddin Haji has extensively explained what is the impact of dyes on human health and ours. So the solution is the treatment first and then the reutilization of the process. So Dr. Abhiruddin Haji has already explained some of the processes which are available in the market. He focused on absorption. So the idea is to use the technologies available and to either supply that treated water to the agricultural land or to reuse it into the textile industries for maintaining different operations. So what are the challenges in operating industrial wastewater treatment? Definitely the biggest challenge is the cost. The second one is the sludge generation. The third one is the energy consumption. And the most important one is the skill and competence. If an industrial operating system, wastewater treating system, is equipped with skilled and competent people, definitely the three problems can be sorted out with their clever minds. What we need to do with all these problems is the effective reactor designs. Okay, there are millions of technologies available in the market, which is proposed to be like wastewater treatment. I myself have published more than 30 research articles for reporting this material, this composite material. The degradation has been achieved 98% and this and that. But nanotechnology is definitely extensively working every sector and it is effectively doing the degradation process. So one solution is the utilization of advanced nanotechnology. That is being extensively done. As I have told you, I have personally done a number of work in this. And the other one is important when we talk about the scalability of the product or scalability of any material which is we are proposing in a small research articles in the form of 1 gram of nanoparticles, that is what we are synthesizing. So it's important to engineerly design a system which can operate effectively to degrade or to remove the dye contents or any pollutant contents to make the quality control that can be circulated in the environment. So here we have proposed a reactor design. We have also displayed this design into the exhibition. You can visit there. This is practically working there in exhibition hall, SCT exhibition hall. The reactor is so designed as it is a glass sheet, a model reactor design. A glass sheet, we have made different channels just to make the contact of wastewater to the reactor systems as long as we can achieve. In a set design, this is what we can maximum achieve. So it is first immobilized with, it's a glass flat bed with a binder layer and a nano powder coating, which we have prepared. It's basically a titanate-based material, and it's not only a titanate material. As we are claiming the sun, harnessing the power of sunlight, so you may have known that the sunlight is not able to impart any potential into the titanate nanoparticles. You have to modify this titanate to tune its energy band gap so that it can work in this sunlight, natural sunlight. So, after immobilization of nanopowders, we have also developed the glass fibers, which is having excellent surface area. When we talk about the implanting of the glass fiber into the rows, so these magic fibers are also immobilized with nanomaterials, functionalized and immobilized with silicon coupling agents, so that make a good contact between the glass fibers, because that is also silica-based material, so it will effectively adhere the particles. So under sunlight radiation, the reactor is supposed to clean the water within effectively visible, physically visible, the inlet water color and the exit water color. So if we are not having the sunlight, so what we do with it? So we have alternative to sunlight is the sunlight simulator. The sunlight simulator is providing the same band region of what is provided by the sun. So this is basically the reactor design, and this has been displayed in the NTU interloop workshop. So utilizing the source of sunlight is not possible all the time, particularly when we are talking about industries. They need to run the system 24/7. So implantation of alternative to the sunlight is important. The simulator sunlight lamp is effectively working competitive to that of the sunlight. So basically, if we compare the spectra of solar light with that of sunlight simulator, it is the exact replica, basically. The Philips company claim, and they also have published this work, that the sunlight simulator is providing the same band and peak and height of wavelength that is being produced by the sunlight directly. So next is definitely the question, what is the quality control of the treated water? And we have achieved amazingly the results. You can see that the COD BOD level that we have achieved after the treatment of one sample under sunlight radiations for 3 hours. These are the results of 3 hours continuous radiation with ambient sunlight, not very high intensity sunlight, ambient sunlight. The results of BOD was 22 milligram per liter, which is far lower than the permissible limit or internationally standard, which is about 80 milligram per liter. And then of COD is 130, and the recommended one is 150 for drinking water. And we are not claiming it as a drinking water. We are just claiming it to use it as a circular path to the textile industry. So this is basically a data which is presenting the discharge of various levels, permissible level, that is permissible for the utilization. So this is the limit that I have already mentioned to, and above is what we have achieved for the continuous radiation and for 3 hours. So thank you very much for practically visiting this full setup. You are requested to be there and you can visit. Many of you have already visited here, but it is operating there, so you can visit it. Any question, please?
Okay, thank you, Dr. Nima. So, open for question. Yes, please.
What do you think, what's stopping the textile industry for the employment of all those three methods, like biological method, physical method, and chemical method?
We are not saying that this system is to be implanted where directly a sluggish system is being coming from the textile. You have to have a screening system first, so that the primary treatment and the secondary treatment, this is basically the tertiary treatment. Okay? You have to have a sludge-free system there now, so that it not made that with fibers or or not impact the bedding structure, we have to perform the primary use treatments to indulge into the second layer.
And what will be the impact or cost? No problem.
Let's stop.
Any working about on cost? What will be impact? If we are using very
we are basically using the TIU based technology. The TIU powder is easily available. And if you, it is basically a 1.5 feet by 1.5 feet reactor, and we have immobilized about 0.5 gram of powder.
The respective cost of chemicals, manufacturing, labor cost.
That is effective. That is not a big deal. That is big deal for the consultant definitely. But I am saying that this is not a technology which you can say that it is a costly technology. If we could negotiate it with any partner or industry, definitely you have to invest for once, and it would be a effective contribution towards your wastewater reactor system.
It's one-time investment and long-time benefits.
Yes, if we talk about the scalability of this project, obviously there is thousands of meter cube of water going per second in textile industry, and for sure we have to use sustainable materials. So how you can relate sustainability with this project? If we talk about the scalability plus sustainability, because we are using glass fibers, and if we talk about the scalability, we have to filter out thousands of meter cube of water, and obviously we have to use a large number of glass fibers as well. How sustainable is it?
That it's one-time investment and a long-time benefits. You have to have spent something, talking about the scalability. You're providing a model. If someone is interested to implant that model in the industry, we can sit and talk definitely. I'm saying the material is cheap in cost. We can develop the fibers for you, glass fibers, and that is definitely there to be cost.
No, I'm not talking about the cost. I'm talking about the sustainability of the material you are utilizing.
That is sustainable. It's a metal-based nanoparticles, and nanoparticles are extremely stable.
What about glass fibers?
What about the
glass fibers?
Glass fiber we have used in multiple cycles, and the glass fiber structure is still intact. The glass fiber didn't catch any color from the effluent at all. It didn't catch any color. If you're providing a fruitful source like sunlight, the glass fiber is not absorbing or absorbing anything. It is acting as a degradation source. Means everything that is coming on the surface of the glass fiber is degraded. There is no any remnant of the pollutant on the glass fiber.
Thank you.
The sunlight simulator is as the sun is also having some UV portion. So sunlight simulator is having UV portion. You ask, am I going towards the right way? It's not UV light. It's a combination of if you move towards the lower intensity, that is high energy, means you have to be very careful about the 20% and we have tuned the TIU materials so that we cannot have to have the light source which is UV one. We have tuned the particles so as it can work under natural sunlight. They are no, it is a photokinetic reactive system. We have to give it energy that is coming from the sun. This photokinetic thing happens. I have mentioned by my talk. It's basically a TIU based composite material. It's not only a TIU, but it is a TIU, modified TIU, and embedded or a composite with another material. That is what we haven't published yet. We have published a work with the TIU long and a modified TIU, but not with the composite material which we have used in the reactor system right now.
I have a question, but not related to your presentation, but we use sunlight simulator to enlighten our solar flares that is installed on the roof at the night time?
So it can be used. That is just a replacement, definitely not as a replacement of sun, but that is providing the source of energy. You can use it for the solar. That is another different sort of study, but yes, that can be used for. As an
I was
energy source.
searching just like such option.
You have an idea now.
Yes. They are processes.
Okay, thank you, Dr. Nimra. Okay, the next presenter is Miss Nida Abid from University of Engineering and Technology, UVT. Please. So the title is Low Pressure and Air Membrane for Heavy Metal and Volatile Space Voltage.
My name is Nida Abid and I am from UVT Lahore. My topic of presentation is low pressure nanofiltration membranes for heavy metal removal. I am basically dealing with the arsenic removal through low pressure nanofiltration membranes. Most of us know that there are multiple types of membranes that can be used for the water treatment. Mostly the RO membranes are used for the water treatment, but the major drawback of RO membranes is their high pressure requirement. For RO membranes, we need pressure from 5 bar to 40 bar. Here I am dealing with the low pressure nanofiltration membranes that lie between the ultrafiltration membranes and RO membranes, and it will be operated on the low pressure from 5 to 7 bar only, not up to 20 bar or the 50 bar. I have developed a spiral wound module using the low pressure nanofiltration membranes. The membranes have been developed. Okay, before going towards the membrane, I would like to discuss some of the statistics of textile wastewater treatment. The major heavy metals are coming from the dyeing section of the textile. The dyeing section of the textile have the physiochemical characteristics as discussed here in this table. For that, for the visible limits of the textile wastewater discharge from different sections has been shown in this table. As you can see that for multiple heavy metals we have limits from 3 ppb to 1 ppb or the 0.05 ppm mostly. And for the drinking water we are only allowed for the 10 ppm limit. That is the WHO is allowing to us to use as a drinking water. Here it is presented that the National Environmental Quality Standards for Municipal Liquid Industrial Effluent for the limit of heavy metals from the NTUs shown here, we have limit for the arsenic, cadmium, copper, nickel and chlorine from 1 ppm to 0.1 only for the cadmium, and every other is the 1 ppm in limit. And as you can see that for every discharge ranging from the discharge into seawater, into inland water and into the sewage water, we have the same limits for all the heavy metals. Okay, arsenic, as I am only discussing the arsenic as a heavy metal here, we can see that the arsenic limits. Arsenic has health effects ranging from the skin to eyes and the respiratory diseases caused by the arsenic. Therefore, we have developed a low pressure nanofiltration module. Using our in-house synthesized membranes. Those membranes have been developed using polyether sulfone, polyaniline, and polyvinyl acetate as a basic materials, and the membranes have been developed in composite form. The composite membranes have been developed for the basically using the PET as a non-woven sheet for the, as I can say that that non-woven sheet has been used as a mechanical support. On that mechanical support we have used polyether sulfone as On the bed, non-moving sheet, I have the 3 layers. Okay, it's okay. Okay. We have the composite membrane. The composite membrane basically depends on the 3 main layers. The first layer is PET layer, non-woven PET sheet. Then we have polyether sulfone membranes that has been developed through Lewis solution process, and then on that layer we have a final pump selective layer based on the polyvinyl acetate and the polyaniline composite. These membranes have been developed by using the phase inverted method discussed as the Lewis solution process, and these membranes have been developed by utilizing multiple loading of polyaniline ranging from the 2 ppm to 8 ppm in the top layer of the polyvinyl acetate layer. Here, as you can see that we have developed 2 different membranes. One membrane is the TFC membranes used and the second one is the mixed matrix membrane. The TFC membranes was developed for the TFC membranes and the mixed matrix membranes both were developed using polyaniline as the basic repellent or the basic absorbent for the arsenic. Okay. Here, as you can see that these are the optical microscopy graphs of the pristine PS, PVA, PS membranes, panel PVA, PS membranes, and the TFC membranes that are based on the 2% panel ranging from the 2% panel to 8% polyaniline. And these are the SEM images for these membranes. The SEM images for the pristine PS, PS panel and PS panel NF membranes, and the cross-section views. Here, as you can see that the polyaniline based membranes using the nanofiltration membranes developed with the help of polyaniline has the nano range pore size, and the mixed matrix membranes have been developed by the polyaniline ranging from 2 to 8%. This is the major equipment that we have used for the testing of polyaniline based membranes. This equipment can operate 2 cells at a time. One is the crossroad cell and the second one is the spiral membrane module. These are the test results for first for the mixed matrix membranes, that is the PS tiny membrane, flagship membrane. As you can see that for the PS membrane, that is the 100% PS membrane, we have only 18% NGSO4 rejection and 80% arsenic rejection. And as we move from 0% panel to 10% panel, we have achieved our arsenic rejection range increases first up to 8% and then it decreased to 79% due to the increase in pore size of the membrane based on the pen loading and illumination caused by the pen. Therefore, from mixed matrix membrane, we have moved towards the TFC membrane. That TFC membrane is the 3-layer membranes, PET, polyether sulfone, PVA, and PADI. And these membranes have shown good results as the TFC membranes have shown the higher rejection and pump flexibility due to the panel incorporated in the top layer. And as you can see, ranging from 63% arsenic rejection to 93% arsenic rejection, that is the very high rejection for the panel removal. Thank you.
Okay, thank you, Ms. Nita. We have more time, about 5 minutes. So, any question? Okay, please.
Can you hear me? This is Dr. Mohammed Irfan. The topic in the presentation was accident and present comes very well. The topic is very interesting for me because
Okay, thank you. Okay, thank you again, Ms. Nida. Okay, if you have any question, after this maybe you can question and answer to Ms. Nida. Right? So the last presenter is Mr. Khalid Hussein from Karachi Institute of Biotechnology and Genetic Engineering, KIBG. Please, Mr. Khalid Hussein.
Assalamualaikum. Good afternoon, everyone. I am Khalid Hussain from KIBG University of Karachi. So I think I am the only one who is defending biological method. So let's start our presentation. So there are three basic needs that a man or women require: food, clothing, and shelter. But people are getting more conscious about the way they dress, due to which Pakistan had become the 8th largest exporter of textile products in Asia. And it's also the 3rd largest producer and 3rd largest consumer of cotton. It contributes about 46% of the total manufacturing sector, and it provides 40% of the employment to the labor force. And unfortunately, only 5% of the textile companies are listed in the stock exchange. So there are several problems associated with the textile industry, such as devaluation of local currency, lack of R&D, lack of modern equipment and machinery, production cost, energy crisis and yarn prices, shortage of gas supply and load shedding, and the last one, water availability and treatment. So our current work is supposed to be focused on water usability and treatment. So our current project supports these 8 sustainable development goals. The hypothesis of this study was the use of bacterial consortium may assist in the decolorization and detoxification of dyes present in textile effluent. aim of study was the development of a critical consortium for the treatment of synthetic textile sewage. Further, aim was divided into 3 objectives: to develop a critical consortium, to treat synthetic textile sewage, and to characterize synthetic sewage. So it's important to screen all those bacterial strains first, the screening of dietized bacteria, and then decolonization assay of dispersed dyes, and enzyme screening of bacterial strains. For this screening, neutral balls were prepared at 37 centigrade, and minimum media was prepared along with dispersed dyes, and the qualitative screening for the bacteria was performed and incubated at 37 degrees Celsius for 24 to 48 hours. So this is the treatment analysis. In this graph, all these bacterial strains were tested against these dispersed dyes. Among them, only these 3 bacterial strains showed maximum decolorization on dispersed dyes. So these bacterial strains were selected for the decolorization of these dispersed dyes. Treated samples, all the treated samples were centrifuged at 20 degrees Celsius for 20 minutes, and cell-free supernatant were obtained for the determination of optical density using UV visible spectrophotometer. This blue line indicates the control or the dispersed blue. We can see in this graph that glutamate rhodopsinones showed maximum decolorization on dispersed blue, percentage about 83%. While in the case of dispersed red, Bacillus thecaliformis showed maximum decolorization percentage on dispersed red. Percentage was obtained about 77%. In case of dispersed violet, Pseudomonas aeruginosa showed maximum decolorization and percentage was calculated around 67%. In case of dispersed orange, Pseudomonas aeruginosa showed maximum decolorization percentage was obtained around 28%. Similarly, in case of dispersed yellow, Glutamate rhodopsinones showed maximum decolorization on dispersed yellow and percentage was calculated around 39%. After the decolorization studies, it's important to screen the enzyme, or we should know that which enzyme is involved in the decolorization of dispersed dyes. For the screening, cell disruption was performed. Enzyme screening was performed using ABDS method, and protein was estimated using Lowry method. So these are the results for the enzymes. Okay, so these results concluded that in case of Bacillus thecaliformis and Glutamate rhodopsinones produce intracellular enzymes and membrane-bounded enzymes, but in case of Pseudomonas aeruginosa, only produce intracellular enzymes. It is important to optimize monocultures before the development of bacterial consortia. So, from the temperature, these all 3 bacterial strains showed optimum growth at 35 degrees Celsius. And from the time, we had concluded that log phase was achieved at 4 hours of incubation. Okay, synergistic test. These are the results of the synergistic test, where we can found that all these 3 bacterial strains showed synergistic behavior to each other. Synergistic means they all are able to grow with the presence of each other. So this is the SEM photograph, where we can see that all these 3 bacterial strains are capable of growing with each other. Textile sewage contain textile dyes, mineral salts, and heavy metals. This is the composition of synthetic sewage that I used in my project. Decolorization analysis of synthetic sewage. So these are the results for the monocultures that treated synthetic sewage 1 and synthetic sewage 2. And these are the results of consortia that treated synthetic sewage 1 and synthetic sewage 2. From these results, C1 and C4 showed maximum decolorization. But due to C1, that C1 contains Pseudomonas aeruginosa, and we know that Pseudomonas aeruginosa is an opportunistic pathogen that may cause any disease, because it's an opportunistic pathogen, and this strain should find any suitable environment to react. So, for the presence of Pseudomonas aeruginosa, we excluded C1 from the study and we select C4. To develop C4, optical density was measured at 600 nanometer from 0 to 6 hours, and spread plate method was used for the colony forming unit. So log phase was achieved for the bacterial consortium at 4 hours of incubation. So these are the colonies of bacterial consortium that contain Bacillus licheniformis and Glutamis bacteriorhodopsitans. C4 decolorized synthetic sewage 1 and synthetic sewage 2 maximum at 18 hours of incubation. These are the visuals of untreated and treated, where decolorization percentage is also mentioned for synthetic sewage 1 for synthetic sewage 2. So from these images, we can conclude that either our bacterial consortium is attached, either dyes are attached into the bacterial cells, or either it was absorbed or degraded. To confirm the mechanism of absorption or degradation analysis was performed. Degradation analysis was performed using high performance liquid chromatography and FTIR spectroscopy. This is the optimization of HPLC. So these are the results for the HPLC, where we can see that in untreated synthetic sewage 1, there are different retention times for these dispersed dyes, and after treatment, no dispersed dyes were found at their respective retention times. So this confirms the degradation of dispersed dyes after treatment.
Mr. Khalid, you have 1 minute.
Okay.
1 minute.
1 minute. You have 1 minute.
You have 1 minute.
So similarly, this was happened in the case of synthetic sewage 2. So these are the optimization of FTIR. So these are the results for FTIR, where we can conclude that no synthetic sewage peaks were found after treatment. So after degradation analysis, detoxification analysis was performed using MPS-SM method. After treatment, our cells for mass fibroblast cells were viable on our treated water. So these are the results of water quality parameters. We can conclude that 50% of reduction was found in case of synthetic sewage 1 and synthetic sewage 2, while slight reduction was also observed in case of BOD and total suspended solids. So we checked our bacterial consortium on real textile effluent. For that purpose, real textile effluent was selected and treated with optimized bacterial consortium. Percentage was obtained around 86%. Similarly, in the case of real textile effluent, 95% cells were viable. So we can conclude from our study that glutamasy bacterial toxidons was the first time reported for the decolorization of textile dyes. Different bacterial consortium successfully decolorized and detoxified the dispersed dyes in synthetic sewages. Analytical techniques confirm the degradation of dyes present in synthetic sewage after 18 hours of incubation. Current bioaccumulation approach is the step towards the treatment of industrial effluents. So our study can be implicated for our future. For the immobilization of bacterial consortium, we can further immobilize the bacterial consortium. Our bacterial consortium can be used as the biorobotics to treat effluent and interplay of nanoparticles and bacterial consortium. So these are the references used to make this presentation. This work has presented at different conferences. The current work is also published in Water and Environment Journal. These are faculty members. Thank you so much. If you have any questions, you can ask through my email ID that is given and also my LinkedIn account. Thank you so much for calm listening.
Thank you. Okay, open Q&A, question and answer. Please.
I have two questions.
Okay.
In your study, you shortlisted two options, C1 and C4. I don't know the names of these bacteria. No problem. And you shortlisted C4 because C1 is not safe, as you were saying that it can be dangerous for some diseases. Then why you should adopt this option for making a study? I think you should drop this C1 option at the start of study because it's dangerous. If something is dangerous for human, for aquatic life, for environment, we should not include in our studies. First question is that why to include this one, and second, I also forgot. Kindly answer for one.
Okay. Your first question has already asked from me in different seminars and conferences. The reason behind including Pseudomonas aeruginosa in our study was in initial days of our research, we were not confirmed about that which bacterial strains can be affecting on dispersed dyes. Because before our research, we were we have no idea about because we have another option. That's why we excluded it from our study. But there is no problem to include Pseudomonas aeruginosa. But for our we can say for our benefit or for environmental benefit, we exclude Pseudomonas aeruginosa because we can't risk it if we have another option.
Okay, and second question is that as per your study, you can use these bacteria and these organisms to remove the dyes from the path and some separate species. Can we use such treatments after the polyester dyeing of the polyester substrates as in normal conventional dyeing? After the polyester dyeing cycle, we have to use the reduction unfixed dyes from the substrates. Can we use such methods to remove unfixed dyes from the dye bath? If we remove dispersed dyes just after the dyeing step, then the drain of that liquor will also be fine, will also be safer and clear. Can we use such bacteria instead of reduction dyeing process? Because I belong to some dyeing background, and that's why I'm asking.
Okay, first of all, we have to understand one thing, that our current study was based on dispersed dyes. In textile industry, there are many classes of dyes like wet dyes, sulfur dyes that are being used in textile industry. So there are other bacterial strains as well that can be
just for polyester dye. We use dispersed dyes for polyester dyes. Only we can use dispersed dyes for dyeing of the polyester. We can't use reactive dyes, acid dyes, bad dyes, sulfur dyes. Your studies about the dispersed dyes, and same dyes are used to dye the polyester, yarns, fabric, garments, etc. That's why I am asking, can we implement this technology in the place to reduction dyeing process, because reduction dyeing process is not safe with respect to our community, our environment, and for the water that we are bringing in our streams. And with the passage of time, we are eliminating RC process from our dyeing process. Can we implement such technology?
Your question is already is mentioned in my presentation, where I mentioned about we tested real textile effluent as well for our bacterial consortium. So this is applicable for your yes.
Can we check?
Yes, you can check.
Okay, last question. Yeah. Any question? Last? No? Okay, thank you very much. Thank you so much.
Okay, now I would like to invite our session chair, Professor Mohammed Yahya, for the distribution of the certificates among our presenters. Our first presenter is Professor Amin Hadi. Dr. Nimran from the National Textile University. The last one is Mr. Khalid Hussain. And for our session here, I would like to request Professor Aminuddin Hadi for the certificate for the session chair.
So ladies and gentlemen, now it's time for lunch and prayer break. We will be back after 50 minutes. For the second keynote session, at about, no, be seated, sir. 1 minute. Sayyadi. Sir. Sir, one thing, sir. Please, Ms. Ikra Abdul Rashid, come on the stage and receive the certificate. Please. Next is Miss Nida Agam.
हाँ ग्रुप फोटो लाओ तेरे खाते हुए
Sorry for inconvenience. Now it's time for lunch and fair break. We will be back after 15 minutes at about 2:25. Thank you.
थोड़ी ब्रेक साधन साफ करके फिर अपन कितने भी टाइम का मोटर फिर साफ करके निकला ठीक है ना
टाइम ना खाना खिलाया करो टाइम ना खाना खिलाया करो टाइम ना खाना खिलाया करो उनको फिल्म में देख लीजिए सारा दिन बताए 15 मिनट चाहिए